Good day, everyone. My name is Rashida, and today I will deliver a brief presentation about the influence of light exposure on Catholyte to SMFC performance. SMFC, it's a short for sediment microbial fuel cells. As we can see from its name, it is a type of microbial fuel cells with an anode embedded in the anaerobic sediments and a cathode suspended in the aerobic water column above the anode electrode. So we have two figures here, the left one and the right one. The left one is basic MFC and the right one is the SMFC. As we can see from the picture, the the main difference between the MFC and SMFC is the membrane, which in MFC the membrane was used to deliver proton from the anode area to cathode area. Meanwhile, the other principle are basically similar. So in the anode of MFC, oxidation reaction will happen, and so does the at the anode of SMFC. And also, the cathode reaction is both the same, the oxidation reduction reaction. So this is a brief introduction about SMFC and MFC. From the figures that we already saw in previous slides, we can see that in both in MFC or SMFC there are three main compartments, which is the anode area, cathode area, and also the electrolyte or the liquid that is consisted in the cells itself. So from the three of components of MFC, the cathode contributes a high percentage of internal resistance of MFC. So it is a critical factor that limits the practical application of microbial fuel cells in terms of cost and power generation. As we can see in the table below, with the surface area of anode and surface area of cathode, we can see with the same sizes, the internal resistance of cathode complies up to 40% from the total of internal resistance, and so on. To overcome these issues about cathode internal resistance, researchers have investigated alternatives like catalyst, electron acceptors, binder, current collector material for the cathode, and so on. One of them is light, because light is an energy source for photo-derived organisms like microalgae and photoautotroph bacteria. So, with adequate light, ferrophytic biofilm can play critical roles in the saturation of oxygen associated with photosynthetic activities in the cathode area, therefore enhancing the cathode performance, as we can see in here in the picture. So in cathode, the reaction that happening is combining the proton and oxygen to produce H2O. So the hypothesis of this research is to give an illumination on the catholyte area by light, and then therefore it can trigger the microalgae or photoautotroph bacteria to form a layers on the sediment water surface. Therefore, they can produce more oxygen at the cathode area, thus enhancing the cathode performance. So this study was conducted to examine the effect of LED lighting on improving the power generation of SMFC using a microscope experiment. As the material and method, the microscope experiment was conducted in Pukyong National University, South Korea, using a sediment sample from Nolcha Bay. So two transparent jars were filled with 2.7-liter homogenized sediment and 1.8 liters of distilled water, as we can see in the picture. So there will be uh, two types of SMFC that were studied. The first one, we call it light SMFC, and the second one is dark SMFC. So, and to prevent the light penetration, the sediment area were wrapped using aluminum foil to prevent light penetration, and one SMFC was placed under the continuous 500 lux LED light, and the other one was placed in a dark chamber. Both anode and cathode were made of carbon cloth um, with the area of 10,000 millimeters square, with 30 minutes of 500 degrees Celsius heating pre-treatment. And the electroanalysis that were conducted was 7 days of anode acclimatization or open circuit voltage operational, 20 days of closed circuit voltage, SMFC polarization, and cyclic voltammetry. Uh, Further explanation about the electrochemical analysis that been done in this experiment uh, is we have three main electrochemical analysis. The first one is the open circuit voltage and closed circuit voltage. Let me tell the difference between these two. So the main difference is the connection, where the open circuits there are no electron flows from anode to cathode because the circuit is opened. It's not connected through an external resistance. Meanwhile, the closed circuit voltage is a closed circuit voltage because the circuit is connected and there is an electron flow from the anode area to cathode area. The OCV or open circuit voltage itself, it's also called by acclimatization stage, and the function is to check the spontaneous reactions or also biofilm maturation on the anode area. Meanwhile, the CCV, it is to check the long performance of the SMFC as a whole. And the second one is the polarization curves. As we can see in this figure, polarization curves itself is plot of electrode potential as a function of current or current density. Polarization curve yields the overall fuel cell's performance under specific operating conditions. Like in the A figure, this is an ideal current and voltage polarization curves. As we can see, the steepness of the graph um, is it shows the total losses of the uh, SMFC systems, or as we can say, internal resistance of the systems. And then, so from these figures itself, this basic polarization, we cannot understand which of the limitations that happens in the SMFC. So by doing an individual polarization like the figure B, we can understand both at the anode condition and also the cathode condition and also the anode condition in here. So by analyzing the potential changes of the anode and cathode at varying current, the performance of limiting factor can be revealed. And the third one itself is a classic voltammogram of cyclic voltammetry. So cyclic voltammetry itself is a simple technique and results are obtained relatively in a short time. So the cyclic voltammetry is the most common and straightforward techniques to determine the mechanisms of electrode reactions underlying oxidation or reduction reactions. In this study, the CV is being done in a 3-electrode setup with 10 millivolt per second scan rate in -1 voltage into 1 voltage of potential range using AGCL as the reference electrode. So this is the results of this research. The first one is the current generation for 20 days. So based on 20 days of closed circuit operational conditions, the current generation of SMFC under continuous light illumination is significantly higher compared to SMFC, which was placed in dark chamber, or we call it dark SMFC. So the light SMFC has an average of 233 milliampere of current generation, while the dark SMFC has only 128 milliampere, which is 45% lower. As we can see also compared to the light SMFC, the current generation of dark SMFC is unstable. As for the maximum power density, normalized by per meter square of anode area, the light SMFC was able to generate up to 32 milliwatt, while the dark SMFC was only able to produce up to 11 milliwatt, which is 64% lower. These results are linear with the SMFC polarization results. So this one is the SMFC polarization result that show that light SMFC has lower internal resistance due to its less steep graph compared to dark SMFC. So along with cyclic voltammetry and also electrode polarization results, we can see in here that both anodes in light SMFC and dark SMFC were compatible as control variables because of their similar performances. So the performance of the anode on dark SMFC and light SMFC was similar in the polarization curves, and the cyclic voltammetry result also shows the same. The shape and also the peak of both anode in light SMFC and dark SMFC is similar. So therefore, it is safe to conclude that the enhancement of light SMFC performance in this study was caused by the improvement in its cathode performance. And the conclusion is the cathode contributes a high percentage of internal resistance of MFC. It is a critical factor that limits the practical application of microbial fuel cells in terms of cost and power generation. This study examines the effect of continuous LED light illumination on Catholyte to SMFC Catholyte performance. And the result shows that significant performance in both current and power generation of light SMFC, which the current is boosting up to 45%, and the power generation of light SMFC is boosted up to 64%. This is the end of my brief explanation about the influence of light exposure on Catholyte to SMFC performance. Thank you for your attention.